Everyone, today I'd like to welcome Sunil. Sunil is the founder and managing director of Ubiquity Ventures. Ubiquity Ventures is a seed stage institutional venture capital firm that invests in software beyond the screen startups, which we'll be talking about today. The companies that Sunil invests in utilize smart hardware and machine learning to solve problems outside the reach of computers and smartphones. He has invested in several companies: Esper, Halter, Kinetic, Parallel Domain, Safe Hub, Sensible, and ThruWave. Before Ubiquity Ventures, Sunil spent 6 years as a venture capitalist with Bessemer Venture Partners, where his work included leading seed rounds in Auth0 and Zapier. Sunil was also a founder and a CEO of a company called Triangulate that was a VC-backed online dating startup. Sunil holds an MBA from Harvard Business School and a bachelor's in computer science from the University of Northern Carolina at Chapel Hill. He spends his free times playing piano, selling, and nerding out on new technologies, and I'm looking forward to hearing about what he's been doing lately today.
Perfect. Well, thank you, Angela. I appreciate the introduction. You can hear me okay, right?
Yes, definitely.
Okay, perfect. Well, thank you everyone for attending today. It's wonderful to be part of this community. I did not attend Rice, wasn't part of the community there, but I've spent the last year getting to know your community leaders, the folks that hosted this call, as well as some of the attendees, and it's quite a vibrant community and one that I want to invest in more and more. So with that, I will begin today's talk that we will focus on what software beyond the screen really is. I will kick on my screen share right now, and I believe you can only see just the stuff you're supposed to see here, which is my keynote. So today we will talk about what software is beyond the screen, what it means when I say software beyond the screen, why it's a lucrative area, why Ubiquity's focused on it. I'll take you through this in about 30 or 45 minutes, and we'll have some time for questions at the end. So if I succeed with today's talk, my hope is that I'll convince you of three really critical things. One, and I hope many of you are already kind of feel this to your core, that software is really amazing. I don't mean the software that runs on your microwave or the microprocessor in your airbag. I mean 2021 style software, whether it's Gmail, Angry Birds, Salesforce.com, the Mac operating system, like that is amazing. We'll dissect why. We'll then talk about this idea that software is moving beyond the screen. It's no longer chained to a computer or a desktop. You can now use it in the real world. It can navigate the real world. It can understand the real world. This is a massive idea, which is really the last point. I jumped ahead of myself. So these three are the goals for today. Now let's, with that, let's dive in. So what I mean by software beyond the screen is really that software is leaping off the screen. On the left side, software has been stuck on a computer for many, many years. It was a big deal when it first came out, and it's had a good run. And good run, by the way, you know, I'm a nerd, but also a business person. Good run means it's changed the world. It's also made a lot of money along the way. In 2007, really, you know, I was a BlackBerry person, but when Steve Jobs announced the iPhone in 2007, it ushered in this new age of software, but no computer nearby. No mouse, no keyboard, no trackpad, no hitting Control-Alt-Delete. You could just whip out your phone and in a second, start using software. It resulted in new companies. It clearly allowed software to address new problems, new challenges. It allowed software to take a kind of crawl a little bit past a computer. For me, this massive trend that I really hope I can get all of you fired up on is this idea that software can now permeate the real physical world. Software can be in everything. Software can run in the real world, navigate the real world, perceive the real world. This is the gigantic deal. I've been evangelizing this idea for a few years. I was at Bessemer Venture Partners for 6 years before launching Ubiquity 4 years ago. So for 10 years, in many ways, I've been dancing around this idea, investing in things at Bessemer, like Rocket Lab, which is a rocket, Spire, which is a satellite, a metal 3D printer, Tile, the lost and found. Those are all Bessemer investments. But they surrounded this idea that you can now use software to control, navigate, perceive the real world. With Ubiquity, 100% of my time, out of this $80 million venture capital firm, 100% of my time is spent on this singular theme of software beyond the screen. Now, this is a little bit high level, so let's slow down and go into a really specific example. When I say software beyond the screen, it's a little more precise for me to tell you that it's really about turning a real world physical problem, transforming that back into a software problem. A very familiar example is taking a photograph. So I believe most of you on the call will have at some point used a disposable camera, 35mm film. You take it to the grocery store or drugstore to get developed. Photos were a chemical process. They became an electronic process. They became a super nice electronic process with a $2,000 Canon SLR. This is a difficult thing to do, but one that I have no interest in. Ubiquity and I think software will be on the screen is not related to the challenges of making better and better hardware. Again, that is hard to do. I'm not putting it down. It's just not where I see the future. I see the future as where you can translate a hardware problem into a software problem on the right side. So the canonical example, emerging canonical example is the $1 camera in your iPhone, right? This is the back of an Apple iPhone 12 Pro, I think. When you, with this $1 camera, it's not very good, but when you pair it with 1 trillion calculations, in the bottom right of the slide, you see Phil Schiller announcing this, I think in October, that they do 1 trillion software calculations each time you take a photo. That's mind-blowing if you think about it, 1 trillion calculations, but software paired with simple hardware can produce photographs that are at parity. So they can sometimes make better photographs. If anyone's into photography, you get a better bokeh effect. With the with the Android, Google Android night sight, you can take photos in almost total darkness. And it's not just that it's taking a better photo, it's also using machine learning to kind of guess at what's in the picture and brighten accordingly. It's mind-blowing, but having smarter hardware can really solve real-world problems better. So with that kind of introduction, the main thesis today agenda will be that we'll talk about where did initial kind of 2021 style software come from, and then we'll spend the second half of our talk exploring what it means when it moves beyond the screen. And this is in the spirit of this great quote that we'll take a trip down memory lane. So the Computer History Museum is in Mountain View. I'm based here in Palo Alto, California. Palo Alto, Mountain View, Redwood City, San Francisco, San Jose, they're all on about a 30, 45-minute radius. Computer History Museum is at the heart of this all. It's in Mountain View, and I was on part of the board for the last 10 years, and going through the hallways, I continued to feel, wow, software looked totally different just a few years ago. And my hunch is software will look totally different in the future. And again, that's the whole bet of Ubiquity Venture. So let me take you down a trip down memory lane. This does not look like a computer, right? It looks like a piece of wood with some old rusted metal. What this is actually incredibly relevant to today's talk. So in 1880, the US was counting people for the US Census. They had people with clipboards marking on a sheet of paper, and they would need to count those to have very important government proceedings occur, allocation of resources and the like. So 1880 census, they counted all these cards. That by the time they finished counting all the cards, it was something like 1887, right? It took 7 years to count the 1880 census. US was just growing so large, paper wasn't cutting it anymore. So there was this company that came up with this simple device. Now let me explain what this device is. Hope you can see my cursor here. On here, you see a card. And what happens is when a census worker would see someone in the field at someone's home, they would have them punch holes in the card to say, are you male or female? What age are you? And other demographic questions they need for the census. This card then had holes in certain places and it was solid in other places. Then what they would do is on the right side, you see, looks almost like an ancient torture mechanism, but what it is it's a whole bunch of pins that have electricity running through them. When the pins go through the card, some of them make it through, some of them don't. Those pins make electrical contact, and what that does is it increments a counter. So this is a really kind of interesting scheme here to just tick a counter, right? You're just trying to count how many holes got punched. This company was able to count the 1890 census in like 6 months. So it was a massive revolution. Now, again, you may be saying to yourself, what the heck? I didn't come to a talk to see 1890 wooden hardware. This company, though, will sound familiar in a second. This company was called Calculating, Tabulating, and Recording, a fairly, I'll say, boring name for a company of this magnitude. A few years later, CTR, Calculating, Tabulating, Recording, renamed themselves to International Business Machines. So in many very real ways, this is the first IBM computer, and it really cuts to the core of what computers are good at and tying itself to a real physical problem. Just a few years later, 50 years later, you had full-size computers. This is ENIAC, one of I think the world's first electronic programmable computer. What that means, though, is that with ENIAC in 1946, computing the trajectory of projectiles, if you wanted to change a line of code, you didn't open up your keyboard to terminal with a green and black screen and change variables in C++. What you did was you moved a wire or you turned a knob. That's how you adjusted a variable. So this is, again, our roots as to where software came from. I was born around this time. I was born in 1982. I distinctly remember putting in these 5 1/4 floppy disks one by one. And for many people and many investors, this is what software looks like. If it doesn't come on magnetic media and go into a desktop tower with this ugly gray color, it's not software. Myself, I graduated from UNC Chapel Hill, as Angela mentioned, in 2004. My summer internship as a 21-year-old in 2003 was working in Office, a Microsoft Office. And at that time, Office was on this 3-year development cycle. So what that means is the product managers, the program managers, the people who design the software would think about it, design, and code for about 18 months. So we'd think of a bunch of features, we'd build them for 12 months, and then they would raise a flag and say, everyone put your pencils down, code complete. That was a very special word. Code complete 18 months later, and then we didn't do anything but test it for 18 months. This is very delicate, important software. It can't break. Don't touch it, just test it for 18 months. Then once it was done, 3 years was finished, we burned a gold master. That means a master CD-ROM here on the left side. We put it in a box. We released it to manufacturing. So code complete, cut the gold master, RTM, released to manufacturing. Those were critical components in this 3-year development cycle. And this is what software looked like. It's, by the way, why you had Office 95, Office 97, Office 2000. Now, what you may know, I'll jump ahead a bit, is every time you log into Gmail, you're getting new code. Google Gmail updates many times a day. It's not once every 3 years. It's changed dramatically. Now, we're all probably familiar with those annoying update screens on your iPhone or Android that says this app would like to update. Now, that seems annoying, but it's a really big deal. And it allows us to leap forward from this monolithic development cycle. I'll skip some of this. Kind of just a cute tidbit here. These 3 look like relatively simple web pages a preschooler would make, but this on the bottom right was the first web page for Netflix.com. The top left was Google's almost their first web page. So websites started this notion of software can be running on a server. It's an old concept, but it popularized this concept to the masses that software could run everywhere. And then you have Tim Cook announcing, more apps in the App Store. But today, there's a lot of code that gets deployed as apps, which is to say, it's in the cloud. You download a piece of it onto your phone. You can use it everywhere, but it has cloud client server connectivity. So this is sort of the journey of software. It started with those holes in a sheet of paper to let electricity through, and it's sort of morphed to this point where there are, I don't know the numbers, millions of apps and trillions of hundreds of billions of dollars being made on code like this. So while we stay on this topic of software, we're not talking about software beyond the screen yet, just on this core topic of software, let's dig in, get a little bit nerdier about what the process is to build great software. I'm an engineer. I still code. I've been coding since I was a little kid. And so we'll go into the technical elements, and I've noticed these all along the way. So I'd say for the last 30 years, this has been true, that there's a pretty good software development tool set. It's been iterated for 30, 40, 50 years. The chair of my old UNC department, Fred Brooks, popularized the mythical man month, and he wrote the software for the IBM System 360 called OS 360, and he also talked about this stuff. The first step in what my view of the software development tool set is that you can stand on the shoulders of giants. Don't build something new when you can reuse someone else's stuff. This is not plagiarizing, it's thoughtful licensed reuse. So we'll ignore how it occurs for a second, but reuse, don't reinvent the wheel. Number 2, get stuff off your plate. Hey, that's not my problem. I'm going to let someone else handle it. I'm going to only worry about my chunk of the project, and other people will give me promises about what they're going to do, and I give other people promises. There's a contract informally between what my code will do and what other people's codes will do. So there's reuse, abstraction, and then I think for me, the final important piece for today's talk is this idea of agility, that you can continually improve things over time. Now, we'll go into each one of these, but I hope it's not controversial that it is precisely because of these powerful tools comprising the software development tool set that you see this fantastic software that we're all basking in today. On the first topic of standing on the shoulders of giants, it used to be, I'm thinking back to like writing in BASIC, you'd write everything from scratch. Even BASIC is theory sits on top of assembly or assembler. So, with all developers today, talk about refactoring. So what this means is if you write some code and later in your program, you write the same code again, every developer has this ethos of, that's stupid, I shouldn't have it in the same place twice. I'm going to take those identical snippets of code, move them to a single function, and everywhere I need to, I will call that function, right? This is what refactoring stands for. Deduplication, DRY, do not repeat yourself. There's different versions of this, but this is an important piece of the puzzle. When you start to refactor, you start to have this idea that this is a function, just like in Excel, you can do the sum function in Excel. There are certain things you pass in, there's certain things you get back. If you write the function pretty well, other people could use your function. You can post it on Stack Overflow. You can have code snippets. Today, the way a lot of folks write code is they Google on the web, try to find something, pull it into their development environment, and this notion of borrowing snippets and refactoring, eventually there's some formality where you can include someone else's code. The hashtag is the way you do that in C++, for example, and a few other languages. But you're including whole hog modules, and there's different libraries, cloud-hosted libraries. CPAN is for Perl, NPM is for Node.js, where you can find a pretty rich set of libraries. That is to say, you can stand on the shoulders of giants in seconds. So then you can not be lazy. It actually allows you to go farther. This is the way that we make better and better software. Auth0 is, as Angela mentioned, a company I seeded back in 2014. Last week, they sold for $6.5 billion. It points to the economic value of software beyond the screen and being nerdy and early. But this notion of APIs are the next transition from I'll write my own function, I'll borrow someone else's function, I'll integrate with a module, or I'll let them host the code. Instead of having to download payment processing code and integrate it into my program, I will just send off a request in the middle of the program when I want something to occur. So this is API-based companies, Twilio, SendGrid, or other examples of this. So this first piece here is, to me, almost the most important, is that to me, it's what allows geometric growth, right? The size of your growth is mathematically true, is based on the size of your base, as opposed to linear growth where you add a certain amount. The next piece here is this idea of abstraction. I've jokingly said this is someone saying, hey, I don't want to worry about it. It's not my problem. Now, if we have any networking people in the room, networking like computer networking, you'll be familiar with this picture here. There's a lot going on. I'll only focus on the left side. We're using Zoom right now. Zoom is a program at the application layer. So when Zoom takes a picture, my camera takes a picture of my face right now, Zoom takes that data, and it doesn't know if I'm on Wi-Fi or local internet, if I'm in California or Texas, or if I'm using a Mac or a PC. Zoom just takes that data, puts it in an envelope, and that sends it down to the next layer. And that sends it down to the next layer. So my Mac operating system puts it into its own envelope called TCP/IP. That puts it into its own envelope called Wi-Fi. That goes across internet, and on the other side, your computers are opening each envelope. The beauty, it sounds like a very convoluted, wasteful scheme, but actually, every layer only needs to know one or two things. It just needs to know, I need to open this envelope or close this envelope, but I don't care how you do anything underneath it. This is why you can plug in your computer, switch to Ethernet, or disconnect and go on Wi-Fi, and your programs on your computer, your web pages, they don't know or care. So this is a really critical piece to the networking model. It turns out in virtually every area of computer science, you have this notion of abstraction, where you're really creating a contract. Zoom knows what the operating system is going to do. The operating system knows what my internet provider is going to offer, right? So there's this social contract. You might call this a header file or an SDK or something like that. There's a lot of kind of wide variation between this, but in the latest incarnation, maybe the last 2 or 3 years, this has become, this has to me led to the growth of microservices, where you have a large company, let's say Toyota or eBay. Each team on eBay is working on different code. It used to be like Microsoft, everyone puts their code into the same code repository. 18 months later, we compile it, we all test it, but we're all working together. Just imagine 1,000 people editing the same sheet of paper. It sounds like a mess. Microservices lets you pull those apart. Each service talks to the other service, and each service has a guarantee of, here's what I'm going to give you, here's what I want back. As a result, this is another elegant part of microservices. Each team can even pick their favorite language, right? You could go to use ebay.com, and some teams can use C++, some teams can use JavaScript, other teams can use PHP, and it actually can work perfectly. So abstraction does lend not only simplicity and speed, but also organizational flexibility, so to speak. The final piece here is informally called Agile or Agile coding. I find that it's very often poorly understood. With regard to starting a new project, definitely a startup, you have to be pretty confident you know the right answer. At that same time, you also have to be pretty confident you don't know the answer, right? Agile starts with this idea that you do not know the right answer up front. It doesn't make sense. It's a contradiction. Really what it says is, I don't know, I'm going to test, refine, iterate, test, refine, iterate, test, measure, improve. There we go, the words I used, in order to find my way to the right product. This is at complete odds with what Fred Brooks in 1965 with IBM 360. My dad's an engineer. They talk about waterfall development too. Waterfall development is kind of like Microsoft with the Office 2003. Let's figure out what the right answer is. Okay, stop. Let's code. Okay, stop. Let's test. Okay, stop. And you never really get to go reevaluate your core basic premises. So instead with Agile, let's look at this graph on the bottom right. This is, let's say one of you working on a project. So over time is the x-axis, you're going to learn more and more about what you're working on, the project, the people, the problems, the nuances of the industry. I hope that's not controversial. However, when you start your new company, you unfortunately have to make the most important decisions. Who's going to be your co-founder? Which language are you going to use? What servers are you going to use? What deployment model? Is it going to be an app, or is it going to be a web page, or is it going to be an Apple TV app? So you have to make the most important decisions here at the top while you know the least. Now, to me, this just sucks. I mean, that's the way the world is, but that just sucks. That by the end of the project, man, do you know a lot about the project and the people and the contracts and the industry. But at that point, you're stuck. You're on this big tanker ship. It's already going 20 knots or 24 miles an hour, kind of humming along, and you can't change your correction, your course. Now, the beauty of Agile is it flips the script completely. It allows you to make unimportant decisions at the very beginning. So again, there's a lot going on, but let's just stay at the bottom left. When you know the least, you can make the least important decisions. That is a really important piece of the puzzle. What that means is you can change whether you're on AWS or GCP, Google or AWS, you can change your programming language, you can change your team, you can have people come in and come out with Agile development. And now you have the privilege of working on things that you can change the most when you know the least. And later, when you know a lot, you can actually make the most important decisions. So for me, this is, there's many different ways to describe this, but data-driven iteration is a pretty good example. And again, where we're going with this is we can use all of these things, abstraction, reuse, and Agile, to design the real world. So it's a preview of about 5 minutes from now. There are versions of this that many people aren't aware of. Stage deployment. So today, when you use Facebook or even Gmail, Facebook doesn't build a new feature and then give it to its 1.5 billion users tomorrow. They don't give it to 1.5 billion users ever, just in a single shot. What they do is they build a feature and then they carefully allow like 1% of their 0.1% of their users to start using that feature. And they watch like crazy. Did it have any bugs? So they test, they measure, they improve. Are people clicking on it as much as we wanted to? Are they utilizing the feature? Should we tweak it? A large part of this is about bugs, but they put it out after 0.1%, then they have 1% of their billion users use it. And then after that, they have 10%. But this notion is you can carefully, with an interactive, iterative product, you actually can slowly test the waters with smaller and smaller audiences. Think about a fancy watch like a Rolex. That is impossible, right? It's a beautiful piece of hardware, but you can't give it to like 0.1% of your users, see if they like the Rolex, see if they break the crown, and then give it to more. You just got to make a thing, lock it in, 2 years later, roll out a Rolex, have a big splashy launch, and you're stuck with whatever you have. Agile is a beautiful improvement on this. So this leads to how I think about founders in startups. I think about them as sort of someone lost in a forest who is trying to get back. They're trying to get back to their cabin, right? They're stuck in the middle of the woods. They lost their way. This to me is parallel to founders hunting for product market fit. This does not mean founders are clueless. Founders are the most brilliant people I know, but it does mean they're hunting and they don't exactly know where to go. Now, if you have Agile, what it means is you have a different way to find your way home. Some smart people stuck in the forest might just say, some bold people might say, I know the way, we should go east. And people follow them. And once in a blue moon, think of Steve Jobs, they get it right. Usually they get lost, they waste a lot of money, and it's a huge failure, right? This happens all the time. Quibi would be the most notable example of this recently. So another way to do this is to walk through the forest and have somebody call you every day. And they can tell you, hey, Sunil, you know what? You're getting cold. You're going the wrong way. Turn around. They call you every day. you'll eventually get out of the forest back to your cabin. If they call you every hour you get a hot or cold signal. What about if you got a hot or cold signal every minute? You can bet you're going to get back to your cabin really quickly. And so for me, I want to back founders. I respect founders. I prefer founders who have this ability to do tight feedback loops, data-driven iteration, great instrumentation to really embody this notion of Agile. So what this implies is not just great, beautiful, elegant software. It also has implications for businesses. We'll all be familiar with a lot of these things. When you buy an iPhone, or when you sign up for Evernote, or you start paying for Candy Crush, you buy the product once, but it gets better over time. iOS, iPhones, you buy one. This is a slightly old photo. We're on iOS 14 now, but you buy the iPhone once, and for free, you get totally new operating systems. That is not how the world worked even 5 years ago, right? Every version of Windows you had to pay an extra $150 for. But today, you get continually improving software. You can choose, do you want to buy Photoshop for $1,000, or do you want to do like me and pay $9 a month, $9.99 a month? This creates a few benefits. One is I only have to pay $9 a month. It could add up to the more over time, but I can decide as I go. Number two, Adobe Creative Cloud is directly invested in my success. That's beautiful. That's a really big deal. If I bought Photoshop 10 years ago, here's my $500, go away, Sunil, good luck. But here, if I'm not happy with Photoshop, I'm going to cancel. This is, to me, a beautiful thing that now we have aligned interests. In many ways, when I sign up for Photoshop, I'm tying my fate to Photoshop, and Photoshop is tying their fate to me. I think that's a good thing. And then what this results is, and you see this with public stock markets and the like, but companies and developers now know exactly what they're going to be getting, or at least most likely what they'll be getting in revenue next month and the next month after. So they can hire people knowing how much revenue they will have over time. This results in better forecasts, better visibility, more long-term planning. And I mentioned this idea of aligning the interests more so. So Twitch was an investment that I worked on when I was a Bessemer. I handed Twitch their term sheet. 2 years later, they sold for $1 billion to Amazon. And Twitch's whole premise here, most people don't think about it this way, but Twitch was a website to go watch people play video games. That's not actually what they were. Twitch was a website that was perfectly timed to capture the transition between pay for video games upfront versus free to play. With games like League of Legends, you can sign up, start playing them, and then you pay over time. Now, when you do that, you want to have a website like Twitch where you can experience the game. More importantly, you can see what level 7 looks like so that you keep playing past level 1. You can continually engage. So with this shift of more aligned interest, once gaming companies cared more about ongoing engagement with their users, websites like Twitch shot up like crazy. So that's the first half of the talk. The second half will be a bit more brief, but this is the core nugget here is that we've talked about software moving beyond the screen. We've talked about the software development tool set. The big aha moment for me, this is a slide you've already seen, by the way. The big aha moment for me was that at the bottom, instead of powerful tools enabling great software, it's now powerful tools can enable smart hardware. Right? The software development tool set is the hardware development tool set. I can be even more crazy, more dreamy, and say the software development tool set is now the tool set for developing the real world. Right? I mean, to me, that's amazing. That's beautiful that we've figured out all these techniques and tools over 40 years of 70 years of hard work, techniques, study, math, science, iterative, and now we can design the real physical world we're in. It can move at that speed and pace. So let's dive into what that means. When I think, so all day long, I meet about 1,000 companies a year as a venture capitalist. I've been a VC for about 10 years. So every day I meet 4, 5, 6 startups for 30 minutes and I'm hearing a pitch. I get to meet very smart people who are passionate about what they do. Unfortunately, I have to say no all the time. After meeting about 1,000 startups, I'll say yes to about 5 a year. So 900 startups I have to say no. And this is part of the framework in my mind as to how to decide. My first question is always, is this software beyond the screen? Now that's admittedly a slightly vague question. So I think through a simple framework. When this person is talking about their product, this guy or gal, does the product they're going to build and the way they will build it, does it follow this iterative agile pattern? Can they do a lightweight test, put something out there, measure, modify, and then push out an update? Having a direct customer relationship, having over-the-air updatable smart hardware, having online learning for machine learning, like these are ways that you can actually follow this pattern. more specifically, the three things I look for very precisely in a product is that I'm going to invest in. Does it have flexible settings? With Zoom, for example, we're all using Zoom. With Zoom, you can do screen sharing, or you can use virtual backgrounds. So there are settings. You can change the way Zoom works. Zoom then knows, Zoom the company, Zoom corporate, has analytics. I think this is not a surprise to anyone. Zoom knows exactly what all of us are doing with Zoom all the time. They don't use it for evil. They anonymize usage analytics, hopefully. But Zoom can then say, only 1% of our users use virtual backgrounds. Let's not waste any more time on that. Or they can say 75% of our users use virtual backgrounds in Zoom. We better put more effort towards that. Then they can build those features and push them out with over-the-air updates. Now, over-the-air is more for smart hardware, but they can push over the internet updates. So Zoom gets better over time. And again, most of us encounter this, I too, as like an annoying, Zoom would like to update right now. And I think, oh my God, I don't want to do this right now, but it actually is the culmination of 50 years of beautiful software development. And so when I hear a new pitch, I want to know, does it have settings, analytics, and updates before I want to invest? Kind of the critical question here. I will skip this slide for now. We'll see if we come back to it. So with that in mind, let me offer a few examples of smart hardware. So let's see. Let's talk about Halter. So what I'll do here is I'll pull open Halter's webpage. So Halter is a Ubiquity investment. It is a great example of software beyond the screen. So Halter has to do with cows. Now, don't look too hard at the cows for a second here. Let's just look at this picture. You see grass, you see trees, you see sky, you see cows. You don't see software. You definitely don't see computers or mice. Computer mice. You don't see power plugs. You don't see CD-ROMs. And this is a great place for software beyond the screen to play a role. So what Halter does is Halter has a solution to help dairy farmers. These are people who raise cows on a farm to make their living. Helps dairy farmers to generate more revenue. That is to say, they make more milk. It also helps dairy farmers to save costs. They can spend less on running their farm. Now, the way that Halter starts for most farmers is with this device here. What you see here is a collar. It goes around the neck of a dairy cow. So this is a piece of black plastic. It's about as big as your head. It goes around the neck of a dairy cow. It has, as you can see, some solar panels, batteries, processing. Very importantly, it has the ability to play a sound, use vibration, a few other techniques to convince a cow to move. So with this collar, it allows you to move and manage your cows. I don't know if this is official, but we jokingly call them cowgorithms. So you have the ability to write code for the real world. You have the ability to read information from the real world, that is to say, where are all of my cows, and write information back to the real world. You can sense and actuate the real world. I believe there are, there's a few examples here. You can create virtual fences, so you can have all your cows not go past a certain area. What you see here is they have not gone past this area as they're grazing. You have the ability to do heat detection, to automatically tell which of your cows is basically ready to get pregnant. You can programmatically shift your herd. So again, if we have some engineers on the call, in Linux, you have a cron job, a nightly scheduled job. So you can set a cron job for your cows. You can do it off of conditional code. So one idea I like is that you could set a cron that would say at noon every day, query my database of cows, find the 5 cows out of 500 that are hungriest, move those cows to the next patch of grass. That is obviously the way the world should work. It is obviously not possible until a company like Halter comes out. So this is a great example of software beyond the screen, setting digital fences and a few other things like that. If you have a chance, I would encourage you to take a look at the website, particularly the videos tab. There's just some great videos about the different features and the way that this great team in New Zealand is able to help dairy farmers. The next example of software beyond the screen I'll pull up is a company called Diligent Robotics. So Diligent Robotics has a solution to help hospitals and clinics to focus on patients. They have an autonomous robot that can go up and down a hospital hallway, helping with dropping off lab samples, supplies, and other helpful tasks. By doing this, the more important clinical staff can actually spend more time with patients rather than walking like you see here, a lab sample, walking it down to the lab, waiting for the elevator, et cetera. So Diligent Robotics, I think they, you can see a few pictures of what they are up to. I believe it was just a few weeks ago, they announced they've done, I think, 10,000 tasks at a hospital in Texas, actually, in Dallas, I think. And so this is an example of software solving something, sensing, actuating. And as you can imagine, this is a pretty flexible robot. So it can be updated, we can monitor. You know, in board meetings, we talk a lot about what exactly was the robot used for. Should we resource our feature development further for those kind of features? Should we accelerate development on picking up lab samples if we're seeing people use that more? Maybe the last example that I will bring up then is, let's see here, is Rocket Lab. So Rocket Lab is part of, to me, a pretty big week that occurred last week. So last week, yeah, it's Wednesday. Last week, investments that I led or co-led during my time at Bessemer, my old VC firm, I was there 2011, 2017. These three companies collectively exited for over $12 billion. These companies were ones where I co-led or led these investments when the companies had 3 people, 5 people, 20 people in that range, kind of early in their life. And all of them have a connection to the idea of software beyond the screen, the ideas we've talked about today. And for me, it's a major affirmation that software beyond the screen is here, it's real, it can make the world a major impact on the world. And as a VC, I have to focus on this. It is very lucrative, right? If you're a founder wanting to make a big splash and make a buck for yourself, if you're a VC, this is an area you have to be focused on, especially with data points like last week, 12 billion in early exits. So we'll talk about Rocket Lab for a second here. Rocket Lab is, as you can imagine here, let's I'll pull up their webpage as well. Rocket Lab is a rocket that launches to space. What this means is that they have a, see if there's a good picture of it launching. They have a 6-story rocket that launches a small payload to orbit. Small means 100, 200 kilograms. Maybe it's about the size of a heavy person. It's about the size of a dorm room refrigerator in volume. So Electron, this rocket, is the only other private company, Rocket Lab is the only other private company besides SpaceX launching to Earth orbit, right? No other private company does this. Rocket Lab has now made it to orbit, I think 15 times. These are all the successful missions. They have, the company, like many of companies I've been involved with, have a great sense of humor. So the return to sender was one of their missions. I can't believe it's not optical. I think the very next mission has got a particularly cute name. They go up so fast instead of they grow up so fast. So Rocket Lab, now let's get to the nerdy science behind it, the software beyond the screen. So Rocket Lab, this rocket launching things to space, for me, starts, the piece that stands out the most to me, there's many innovations, but Rocket Lab is the world's only rocket that has an electric pump-fed engine. Every other rocket that's ever launched to orbit has a mechanical turbopump. To put it simply, the most important part of a rocket is its engine. The most important part of an engine is how do you throw fuel into the combustion chamber fast enough. The solution for every other company on Earth looks like a small engine with explosions turning a turbine that pumps fuel really quickly. That's called a turbopump. For the purposes of today, you can think of it like a beautiful Rolex. It's a very delicate, perfectly engineered hardware device. Rocket Lab said, we're going to zig when everyone's zagging. Rocket Lab has electric pumps. So these red things you see on here, they're not actually red. They're just red for the demo that Pete had here, Pete the CEO. These are electric turbopumps. This is an old photo, but Pete's innovation here, this, by the way, on the right side is Peter Beck, the CEO of Rocket Lab. He had this idea that he could use software, C++ and other code, to adjust how an electric turbopump could pump fuel into an engine. So now what he could do is build, design, iterate an engine with lines of software. Very precisely, when he was making this engine, this is called the Rutherford engine, he could try something out on the test or the test cell on the launch on a test site, turn on the engine, see if it combusted the right way. If it didn't, everyone else on Earth would have to take the engine apart, go to a metal shop, make a new piece of metal, bend a new piece of steel. Sorry about that. Put it into the, after they take a few weeks, make a new piece of steel, reassemble the engine and test it, right? That's when you iterate in hardware. Rocket Lab tried something, didn't work, went to a computer, adjusted a variable in C++ and tried it again. They could try things every 5 minutes as opposed to trying every 5 weeks. So for me here, it's a really big deal to me that what happens is that you have the ability to now iterate your engine with lines of software. And Rocket Lab spent somewhere between 100 times less money and 1,000 times less money to build, design, and launch a rocket to orbit. This is a really, really big deal that you can improve your speed and how much money you have to invest to get something working when you iterate in software. And this has been true for many of these companies and this notion. So I put some more details about Spire Rocket Lab, the exit last week for 1.6 billion, 4 billion, and the exit of Auth0 for 6.5 billion at my blog at blog.ubiquity.vc. Those are investments when I was at Bessemer, but I still analyzed them and sort of shared some lessons for the future. What I hope I've been able to tell you today is really that software really is amazing. It's moving beyond the screen. It's a big deal. And if you really look for these things of settings, analytics, and updates, and try to build a business around these core ideas, and a flexible business, you can now go after new problems, greenfield problems no one else is thinking about, and hopefully have a little more success. So with that, I can pause here and let Angela, you can take back over.
Hi, Sunil, thank you. That was a great talk. You've already gotten a few questions. I really like this one. Do you think the biggest technological innovation over the next 5 or 10 years are achievable using existing hardware? In other words, is hardware a limiting factor for innovation, or is it all driven by software?
That is a very good question. I have to. I'm a little nervous about answering with that first part of the question, the biggest things that will happen in the world, but I'll get to the spirit of the question. I think we've got really good hardware already. I don't think, if I were to think about, 1890 with the, it's called the Hollerith machine, Herman Hollerith, the first IBM machine, that was hardware limited, right? We didn't have processors, semiconductors, batteries, IMUs, gyros, servos. We have all of those things. And I have a 4.5-year-old daughter. We play with Arduinos. So like you can buy for $20, or you can buy a Google machine learning Coral board. It'll do machine learning processing for $100. It's all dirt cheap and it's all out there. Now we will, I'm sure, create new, better hardware things, but we have most everything we need for a while. I think there are years, maybe decades of innovative opportunities yet to be exploited just with the right software. And increasingly, you don't need to know much about the hardware. I think the Amazon Web Services example is pretty good. Today, this is true, in 90 seconds from now, you could have your web page being served to the world, like starting from nothing, sign up for an AWS account, push a button, spin up a server, put your code there. You don't know where the server is, what it's plugged into, how it's cooled, any of those things, it's abstracted away. And I think now with these different elements of smart hardware, you can now write code without even having to know exactly how a motor works, exactly how voltage works, exactly how to screw things together. There are companies, for example, that will do low-run PCB manufacturing. Tempo Automation is one. Well, they'll make your circuit board for you. So I do think the implication of this is you can live in software and have a massive impact on things. We don't have to wait for any new hardware.
When you were talking about I kept on thinking about like quantum computing. That is like one of the few areas where it's like we do like where hardware is a problem, or where hardware is definitely still a challenge. How do you think about that area, or do you kind of like, are you waiting?
Yeah, I will punt on talking about quantum because I'm not smart enough yet. It is on I keep a list. I think of Ubiquity as a nerdy and early VC firm investing in software beyond the screen. So I keep a list of topics that I'm going to eventually nerd out on, and I'll put a few things. Can I message the group? I think I can.
Oh,
right?
yeah, you definitely can.
So I'll put a few things in here. That's a blog post I wrote about the word nerd. I say the word nerd a lot. I have a very specific definition. It has nothing to do with thick glasses. It has to do with being obsessed with something about 100 times more than other people and having a deep passion for evangelizing it. I'm obsessed with piano. That means I know the name of every part of a piano. I love to tell you, if you came over to my house, I would love to show you every single part of a piano. I'm the same way about sailing. I'm the same way about smart hardware. So this notion of being nerdy and immersed in this stuff, I think is really important. I don't have that with quantum yet. So I'm skeptical. I'm careful not to talk about it, but it's on my nerd list to eventually
well, there's so many other things to
nerd out
do
about
right now. So,
but I'll touch on one element to this. One of the things that I do is I recommend, I wrote a blog post, I'm going to put it in here as well. It's called How to Stay Nerdy During a Pandemic. And it's really one of my secrets. This is almost a public session, so I won't say secret much longer, but staying nerdy during a pandemic, it's this idea that like YouTube and YouTube technical videos, they're fantastic. I mean, the blog post starts, for example, with 3 Blue, 1 Brown, a fantastic YouTube creator that explains a lot of math and math and coding concepts. He has the single best explanation of machine learning that I've ever seen. And you can start with knowing nothing at all about math or science or computer science. And within 20 minutes, you'll know more about machine learning than like 90% of people I talk to. And so it's really, really helpful to sort of, so long answer, Angela, pretty soon I will go YouTube nerdy on quantum. And so give me a few weeks and then I can answer that more. It does look very, very promising, but I'm not familiar with the current state of affairs.
I agree. YouTube's your friend. Everything's there. Next question. What is the constraining factor to software?
Let's see. Pretty broad question. Constraining factor to software. I'm not exactly which way to take this. It does take a little bit of time to build software. It takes, today, I think, almost anything you can conceive of can be built in software in a matter of months with a matter of a handful of people, right? Like that is a ridiculously bold statement. Anything you can think of, we can probably build with 5 people in 6 months, right? Like it may not work perfectly, but like that was not true 10 years ago. Like there were things you could think of that $1 billion would never get you to work. And so the constraint in my mind is not the writing of the software. It's either the user interface, thoughtful user interfaces, making it intuitive, figuring out the right features. This is in the Steve Blank customer development side of the house. How do you find the right people? No business plan survives first contact with customers, like that notion. And then the other piece is, at least with regard to software beyond the screen, I think a lot of software beyond the screen has an even higher reliability requirement. What that means is, I had a slide in here with the blue screen of death on Windows, but you can't have your light bulbs crash, right? You don't want your toaster to reboot. So you don't want your car, and I used to have a Tesla, I don't anymore. It would reboot while I was driving it. It was terrifying. So there's a higher requirement for sort of fallback, redundancy, and better written code or better techniques or better code reviews to make sure that you're not building fast and moving fast and breaking things in the real world.
Could you please provide some examples of what you consider smart hardware?
Yeah, so yeah, if you're up for it, I'll flip on the screen share for another minute, and I have a few other examples that I think are pretty fun. I jumped over a lot of these slides here. So other examples of smart hardware, I informally mentioned a Tesla. There've been a few kind of casual pictures of them. One very neat thing, neat implication. It's a few years old. It's 3 years old here, but Tesla, I'll come back to the slide in a second. So Tesla, they have a car that's almost a computer on wheels. They have 3, this is a roughly accurate story, by the way, it's not totally accurate. They have 3 models of Teslas a few years ago. They had a 40, a 60, and an 80. The Model S40, Model S60, Model S80. What that really means is they had a 40 kilowatt hour battery pack, a certain amount of energy, so you could drive 150 miles. The Model S60, you could drive 200 miles. The Model S80, you could drive 250 miles. So their thought was, different people have different amounts of money, different budget, and we'll make different cars to adapt to the different budgets. They'll drive different distances. 3 is actually a fairly big number in manufacturing, so they only made 2 cars. They made a Model S80 and a Model S60. So how did they have a Model S40? How did they have the cheaper version? Well, they put the same battery pack as the 60 in the 40, but with software, they just locked the last 30% of the battery. They software limited how much of the car you could use because they sold it to you at a much lower price, and they didn't, it was actually Some people have visceral reactions, why are you buying something that is locked? Isn't it bad for the world? Well, I think in many ways it actually can be better for the world because you don't actually have to have 3 manufacturing lines, 3 different kind of configurations. You just have 2, and then with software you limit 1 down. This is actually a fairly common thing to have dark sensors or dark equipment in your stuff. Now, with that context in mind, 2 models that look like 3 because of software, a hurricane hit Florida in 2017, and Tesla, maybe because they're nice, maybe because they want good press, they unlocked the capacity of again, it's an approximately correct story. So maybe they unlocked the capacity of the 60 and 80 to 70, but I'm going to say they unlocked the 40 kilowatt hour battery and allowed you to use all 60 kilowatts because in the hurricane, they wanted people to be able to drive farther. So this is a pretty neat idea that like the world can change even after you buy something on a whim. It has implications for like, man, companies have a lot of power. It's we got to think through that as well. Another example of software beyond the screen, I'm actually going to do an event on this in a few weeks. Maybe I'll ask Angela to share the information about this. A Ubiquity event about the Mars rover. The Mars Perseverance rover just landed, I think, 2 weeks ago on Mars. For many reasons, it doesn't make sense to, well, there's 2 parts to this. When we launch the Mars rover, it takes about 9 months. It does something called a home and transfer and slowly gets to Mars. Over those 9 months, we could think like Microsoft in 2000 and write the software, put it on the rover, cross our fingers and let it go. We don't do that. What we do is we send the rover, and then for the next 8 months, people on the ground keep writing the software. So this is not totally accurate, but you can think about it like the Mars rover launches without a brain. It doesn't have any code on it. It's empty. And then over those 8 months back on Earth, we're writing the software, testing it, writing it, testing it. There's a digital clone on the Mars yard at JPL. Eventually, we finish the code. We're like, okay, good. Let's send it over about a few weeks before it's going to land. So it's kind of like cramming right before a big exam, right? You get to, and then we push the code over the air. So another example of software beyond the screen. The event that I'm going to host in a few weeks is going to be about how the Mars rover actually runs an element of machine learning. It runs an autoencoder to do novelty detection, because when it's looking at a rock or looking at a landscape, it can locally decide this is interesting because I've never seen something like this before, or this is boring, I'm going to keep going to the next rock. So you don't want to have to joystick from Earth with the light speed delay, the rover. So you want to be able to give it either a sequence of commands, that's what we've done in the past, or give it logic it can run locally, machine learning powered logic, so it can decide what to do. There's the blue screen of death. Other examples, I guess we've talked about a few of these. Maybe another example, in my house, we have these Hue light bulbs. They're software defined, so you can change everything about it, and they cost $15. That summer of 2003, all the interns had this incredible privilege. We got to go to Bill Gates' house in 2003. He used to have all the interns over. At his house, I'd read about it in this book, The Road Ahead. He had kind of lights and screens and all sorts of stuff that would respond to you. He at the time was the world's richest person. Today, you can have all of those things for like $200, right? I mean, this is the cost curve of reduction for what we used to cost even today, like $30,000 professional home control system. You can replicate it with 5 of these light bulbs and a little iPhone app. So software beyond screen is allowing more and more to permeate, and it's showing up in a lot of different places. So I'll pause there for answering that question, Angel.
Every time you go beyond the screen to the real world, you have to deal with problems of reliability and safety. Is this angle an issue at your level, and how does it play into the equation at all?
Yeah, it's a great question. I've touched, I think since this question maybe got posted about 10 minutes ago, I've touched on it a little bit. It's critical. It's absolutely critical. It raises the bar dramatically again, maybe I really wish I could see the audience, because then I would have asked a bunch of survey questions as to who's heard of 5 nines, for example. But in the computer world or networking world or hardware world, there's this notion of how often something is allowed to fail, how bad it is. And you could say something is going to work 99% of the time. That's pretty good, Sunil. Well, what that means is in the course of a year, you can not be working about 3 days, or you could say 99.9%, or you can say 99.999. 5 nines is a very special metric. I'm gonna just double check so that I don't mess it up. I think it's 3 minutes. Yeah, 5 nines means that you can only be offline 6 minutes every year. So if Google or Amazon Web Services says they offer 5 nines availability, that means out of the whole 365-day, 24 hours a day year, they're only going to be down on average six minutes or less. That's a really big deal. Now, I would argue for some things, it needs to be even higher than that when you put software in the real world, right? Like Tesla does not do this. It's disappointing or shameful, but like the self-driving needs to work at a higher than 5 nines of reliability if I'm going to put my 4-year-old daughter in the back without being in the front seat, right? So it's a really, really high burden. I do have investments that are related to this. A Ubiquity company called Parallel Domain, I'll put these in the chat as I talk about them, is a company that trains autonomous systems by using procedural content generation to build synthetic data available by an API. That's a mouthful. Parallel Domain makes fake pictures for self-driving cars to use as practice to learn how to drive. As a result, they can get better and better. And you don't have what Uber did. Uber killed someone in 2017 that was crossing a highway at night in Arizona. Terribly sad. Uber had never seen that example before in their machine learning training data. Another company I've invested in from Ubiquity is a company called Eclipsium. So Eclipsium is a company that scans firmware looking for malicious code. We have pretty good regimes around scanning software with Norton antivirus, McAfee antivirus. They run your computer Malwarebytes. But what's absent today is your BIOS in your computer, your thermostat, your car, your watch. Like these things can get hacked. Your microwave could get hacked. 10 years ago, who the hell cared? Today, I don't know, because my microwave can listen to me now. It could boil something, it could explode. The battery in my computer could explode. My car could be driven off the road if the firmware is hacked. So this question I really resonate with, sort of thinking through the second and third order implications of a software to be on the screen world.
Okay, so you're getting so many questions. We're running out of time. So
Yep.
sorry, everybody, I'm not going to get to everything. What are the commonalities you see in successful founders? Is having programming technical expertise a prerequisite to success?
I like it a lot. I tend to enjoy hanging out with technical people more than non-technical people. I have backed non-technical founders, so it's not a prerequisite, but I find that if you're innovating at the edge of what's possible, it helps to have an intimate familiarity with these techniques, these approaches, and for knowing which direction to head, but also recruiting other technical people with credibility. So not at all a prerequisite, but in general, it makes it a bit easier to do a technical business if you're technical.
Yeah, I mean, you know how long things should take. It's easier to manage a team. You can speak the language. It's just,
Exactly.
yeah, it's a huge plus. And I think everything, I don't know, everything is coming back to programming and code nowadays. So what about a hardware that is, okay, I think that this question's follow up to the smart hardware question. And they're asking if a hardware that is reprogrammable, do you see that as smart?
It could be, yeah. The reprogrammability does address this idea of settings, analytics, and updates, perhaps. It definitely has settings because you can change it, like a FPGA is programmable, right? If you have analytics, now analytics is not a critical component of programmable hardware, so you have to add your own analytics layer. But yeah, that would help you to close the loop. So that is a piece of the puzzle. Reprogrammable hardware is another phrase for smart hardware, provided you get to see how it's doing in the real world, not just, otherwise you're just throwing darts without knowing if you're hitting anything. So you want to know if you're hitting something, refine your aim, and then try again. So Angela, I would love to make myself available for folks as well. I will put my email address in the chat. I'll also put it right next to a blog post I wrote about the right way to network. I would love to network with everyone here, but I'd ask you to please look at that. I love meeting entrepreneurs, but I also love making things a two-way street with regard to, like, let's learn about something technical together. Let's talk about sort of things we can both benefit from. If you have an investment I could invest in, I would love to hear kind of what it is in a few sentences. But if you take a look at that post, I will answer, I promise, every single one of your emails today. Ubiquity is a one-person firm, so you're going to get a hold of me, and I'll definitely answer you. So thanks for having me. It's been a privilege to talk with all of you, to see your questions, and be able to share the theme that I think is the most exciting thing going on right now, which is software beyond the screen.
Thank you, everybody.